Ladies and gentlemen, it is time. Welcome back to another installment in the devlog series for Nightmare World. Yes, it's been quite a while between the last one and this one, and not for bad reasons. Between the last devlog and this one, there have been a mammoth amount of changes, and all of them for the absolute benefit of the game moving forwards. Now, in this devlog, you're going to see something a little bit different. This logo has now changed to this. That's right, we've moved to Unreal Engine 5. And to explain what that means for people, I'm going to give a quick explanation before we get into what we've done this devlog. Now, for those who don't know what a game engine is, consider it like this. You are a plumber. You are going to a job. When you arrive at that job, you are given by the client a toolbox with certain tools in it. You don't get to decide what those are, they're there. You have to make do on that job with the tools in that toolbox. That toolbox is Unreal Engine, and the tools inside it are dictated by Epic Games in their development of said game engine. Now, what has happened between Unreal Engine 4 and Unreal Engine 5 is that tiny toolbox has been taken away from us, and we've been given a cabinet full of every tool we could possibly wish for. Ladies and gents, when I say that game development boundaries have just been completely shattered, I truly mean it. And we're going to be taking a deeper dive into what those boundaries were and how they have now been removed for us, and what that means for Nightmare World going forward. So, without further ado, sit back, grab a beverage, get some popcorn, and enjoy. Now, while the move to Unreal Engine 5 was incredibly smooth and honestly went better than we could have hoped for, there was one thing that didn't. This is involving networking and the back-end server stuff, so we're going to dive quite in depth here, as you guys have actually told me that you would like to hear the nitty-gritty and the finer details of what we're doing. And that's understandable, as a lot of the things we're saying we're doing don't mean anything if we don't explain it to you. So, let's jump into what's been going on with the programming team over the last couple of months. After we've prototyped many systems, much of which we've not yet shown off, we ran into several snags. One of the first we ran into was we tried using an open source, open world system for Unreal Engine called OWS by Saberdart Studios. There's a lot of credit for what Saberdart is working on with OWS, but it was just very opinionated, and we weren't sure whether it would scale for the action combat MMO experience that we were shooting for. That's not to say that multiplayer for Unreal Engine is easy, it isn't, but we want our solution to feel natural. So, when we transitioned to Unreal Engine 5, we had it already on the agenda to do major rewrites to OWS. We'll go over some of the reasons and our proposed new solution. It's important to understand the real hurdles every developer faces when they tackle the idea of multiplayer in Unreal Engine. A. Servers are explicitly server-client architecture. B. An Unreal server can only run a single map at any one time. C. You must BYODB, bring your own database, for persistence. OWS's solution was to separate every map in Unreal Engine into a zone, and have the client server travel to other Unreal instances should the client transfer zones. OWS also shards zones by spinning up additional Unreal server instances where the player count reaches a maximum of 100 players per zone. Players have no ability to interact between zones or shards. So this is a pretty good solution for the vanilla adaptation of the Unreal Engine server code. The major issue this creates is that it forces us to have load screens between every potential map, which sounds like a setback at the least. The best way I think I could describe the player experience would be like running around the world in EverQuest 1. You'd hit a loading screen every time you wanted to go anywhere. Part of the issue is at the core of the source code for Unreal Engine's multiplayer code. It just doesn't allow for the smooth transitions of a client from server to another server. Technically it does, but it would involve transitioning the map for the entire server along with all current clients, which is completely nonsensical for this use case. Great for Fortnite though. Even though this solution would not be ideal already, what pushes it further into the untenable category is when you take practical level design into account. A very real possibility exists that we'll need things like large houses to be their own levels in a large town or city. We really don't want to force players into loading screens, especially if they be relatively arbitrary. The other thing racking our brains in the background was how we were going to save things like persistent buildings that had been dynamically created. Although OWS has the ability to save persistent map data in its database, it feels like it failed to account for the sharding system when it's multiple players placing contradictory objects across multiple shards of the same zone. Imagine you've got 100 players, 50 are in each zone. It's the same zone but duplicated. Well, if a player places something in shard A, does it get replicated to shard B? The answer is no. Finally, the communication layer between the game server and the database in OWS was entirely REST-based, meaning it relays data over the HTTP protocol. We felt this approach was inappropriate for the amount of data that would need to be transferred between the two. There were also item duplications and other general security issues with OWS. The team has spent months trying to fix a lot of these issues, and I know Dartnala is working on them over there as well. But we felt it was time to move on in culmination with all these other issues. So where were we to go from here? The choice seemed obvious, though painful. We had to re-engineer our networking solution ourselves. The key takeaway for any solution we would come up with is that it has to be as least intrusive as possible, but also had to give us everything we wanted. The first step was to think about our data persistence layer and how we wanted our game server communicating with our database. We settled on a WebSocket microservice that will interface with our Postgres database. So far, not that much has philosophically changed from the OWS implementation, except for the fact that the communication happens over the WebSocket rather than HTTP, which should have far less overhead in the long term. The second thing to think about were those pesky load screens. Since server traveling the clients is off the table as a general principle, something had to be done. It became apparent that we were on a mission to figure out why vanilla Unreal servers couldn't have 100 players playing at once. The answer is pretty simple. They don't need to. I know, fairly anticlimactic answer. Perhaps it's more satisfying to say that it wasn't what they were optimizing for. There's no hard-coded limit, things just start to break down because of things like server-based actor authority checking and tick functions. We decided that our WebSocket concept that we had created to store dynamic data could also be used to share that data between game servers in real time. So the rough idea is that when a player connects to one of our servers, their gameplay will be authoritatively dictated by the server and their dynamic content can be served by a WebSocket layer. We can also select one of our servers to serve a particular client geographically, rather than serving them based on a particular map, decreasing latency. So a client's world would either be geographically or manually selected. Since the servers themselves will share an internal network, the fact that the internal communication choice is TCP versus UDP is actually an advantage rather than a disadvantage. These communications need to be fast and reliable. So, with all that techno-babble out the way, it's time to talk about the thing that many of you have been waiting for. Unreal Engine 5, and more specifically, Nanite. And again, I'm going to assume that not all of you know what Nanite is. So, essentially, in short, it is a gift from the gods. This previously mentioned bigger toolbox is basically carried on the shoulders of Nanite. And for any of you out there that's about to say that a bigger tool isn't necessarily better, I am deeply, deeply sorry for your loss. But in short, Nanite is a tool that reworks the way we think about geometry, that is the 3D stuff in the engine, on a basic game development level. In traditional game development modeling, or more specifically, the use of said models in the engine, essentially the way this works is if the player of the game is looking somewhere where they can see any part of a model, for this example we'll use a mining rock. If the camera can even see 1% of that model, it will load in the entire model into the graphics card memory. Now, that doesn't sound terrible because, hey-ho, you're only going to see that 1%, right? Well, it matters a lot, actually. Let's use a different example. Let's use an entire cliff face. If you can only see 1% of the cliff face, it is utterly wasteful to load the other 99% of that model into the graphics card. More importantly, graphic memory. And this is what we call virtualization of 3D meshes. It's virtualized geometry, and it is the holy grail of game development for the last god knows how many years. Well, with the release of Unreal Engine 5, we now have that in our hands, and how this works is essentially you only see the polygons on the screen that you see on the screen, but this time, so does the graphics card. The models are split up into what they call cells. It groups together a small amount of polygons and basically says, hey, treat this like a broken vase that you can put back together. Except don't put back together the bits that the player can't see. Now, this is where this technology gets extremely, extremely exciting. Because previously, game development scenes or levels had a budget of around 10 million polygons for lower end games. Well, you can now use that entire budget on a single in-game asset. So for example, our very early blockout sculpt of the world tree that we're going to be using in the Sporrid Village, that's 2.4 million polygons. And there's something exciting about that. The FPS doesn't change whether it's there or not. And this is what we're going to talk about next. Nanite seems to be this black box of magic. You can truly add as much as you like to your scene, and it gets to a point where it doesn't slow down anymore. Sure, initially you're going to get an FPS drop the more junk you throw in a scene, but remember what I previously said. If it's not being shown, it's not being rendered. Well, let's say you've got a canyon that is very low down and you're in the middle of it, and all over the walls is meshes, and they are all loaded in because you can see them. Well, now when you add a 2 million polygon tree into the middle of that canyon, you may be thinking, oh damn, that's another 2 million polygons to render. Wrong, because now everything behind it, including the cliff faces that are occluded, are not being loaded in. So it's a game of hot potato in the game engine and in the graphics card memory of what is and isn't being loaded in. When you get a scene pumped to capacity with meshes, you really notice there's a fall off in performance loss to the point where there's eventually no performance loss. And I'm sure there's a lot of people who haven't tried this that are thinking, that sounds too good to be true. That sounds like nonsense. And I will be honest, I thought this too. The entire team were waiting on bated breath for the release of Unreal Engine 5, and specifically Nanite. And we tried it out, and well, we did think it was too good to be true, but because of a mistake that we made, and a mistake that we're seeing lots of other game developers make that we want to talk about here, purely because we don't find any documentation that raises this issue. And again, it's not an issue on Unreal Engine's part, it's an issue on the way we're thinking about making games now. So we loaded up our project in Unreal Engine 5 day one and enabled Nanite on everything. And the performance barely changed. We got an extra 2 to 3 FPS and were utterly disappointed with the results because it's not enough to make it worthwhile the change. However, something that we had completely overlooked is that new technology needs to be approached and used in a new way. My advice for any game developer going from Unreal Engine 4 to Unreal Engine 5, and if you're an artist this is especially relevant, forget everything you know about optimizing assets for space or resources. Now, I know there's going to be an absolute Mexican wave of facepalms from all the developers and all of the artists around the world, but hear me out. Traditionally in game development, we have used something called maps. These can be normal maps, ambient occlusion maps, or even just deformation maps. Now, these were invented, and specifically we'll talk about normal maps, to fake geometry to save overhead performance. And that's great because geometry was expensive, right? Well, now we have almost infinite free geometry in any scene that we want to create. We don't need these textures anymore. And when you look at a 4K normal map for an item to fake geometry, well, adding more and more of these normal maps is an exponential curve of how much memory is being used in the graphics department, whereas geometry is no longer doing that. This was such a light bulb moment for us that we had to rush and check it out right away. And sure enough, we are now modeling in the detail instead of faking it, and we are getting double or triple in some cases the performance that we would have without Nanite. And this is where this exponential kind of calculation gets even worse. We've only mentioned about normal maps. Now imagine that this item, again we'll use a mining rock as an example, is using a normal map, a tessellation or displacement map, and an ambient occlusion map. All things that we use to fake extra depth and geometry. Well, you've now got 3 4K or even in some circumstances 8K textures that are actually a detriment to the process and don't help in the slightest. The fact that you can now get the result you're after without fakery at a lower cost, and in certain circumstances an exponentially and infinitely lower cost than what you would do with maps, well, why would you use maps anymore? And the actual answer to this question is, you shouldn't be. If you're looking to leverage the full horsepower of Nanite as we are now, ditch the maps. Stop using things to try and fake geometry, because you don't need to anymore. So that's what we've done. We've got rock and tree meshes in the game that are sitting at around 500,000 polygons per instance. And Unreal just handles it. It doesn't care. So let's have a very quick look at the art direction and changes that have occurred thanks to Nanite, Unreal Engine 5 and Lumen. A dramatic shift in graphics technology moving from Unreal Engine 4 to 5 has presented a great opportunity to begin working on a new art style and direction, which is designed to take full advantage of Nanite and Lumen technology in Unreal Engine 5. Technology which allows for a more sophisticated real-time lighting and extremely higher polygon counts, the likes of which no one on the team could have even imagined having to work with. More emphasis is being put on sculpting higher polygon assets to be used in the game with less use of texture maps for details. New shaders are being created to support these new workflows, make heavy use of vertex color data and world space overlays for extra subtle painterly surface details. The textures and end results are heavily inspired by the watercolor-esque backgrounds of Studio Ghibli art. One such shader allows the artist to paint 3 different materials using the red, green and blue color channels to determine what textures to use, and also use the alpha channel for light to dark shading. In the example shown, the red is used for the tree bark and the green used for extra moss coverage. Think of it like using masking tape while painting. Many other new techniques used have been inspired by pre-rendered animation and film techniques to use 3D in order to fake 2D, which were previously too costly, but due to the increase of polygon budget thanks to Nanite, they are now able to be used in real time for games. Techniques like using a simplified surface normal over a high fidelity mesh, like on these trees, allowing for very complicated shapes to be shaded in a simpler, smoother and flatter lighting to give the illusion of a more painterly look. These also work with the rest of our foliage in our new seasonal colouring and weather system, including snow and much, much more. Characters have also seen a complete overhaul and have a new art direction inspired by the art from Arcane, the animated series. We've also begun designing the characters' costumes and undergarments. These are still very early in development though. And of course, this video would not be complete without an update from the sound team. The sound team has been hard at work honing their sound design skills with some very early sounds, some of which have already been implemented in Engine. Footsteps for dirt, medium grass and long grass. Bubbly swamp pit, made from boiling water, a plastic sensory toy, and mouth sounds. Forest ambience, spatialized audio for birds and gusts of wind, as well as some background brown noise ambience. Small stream, brown/white noise layered with recorded stream sounds and parameter-driven distance attenuation. Christ, that was a mouthful. Build kit placement. We started with 4 material placement sounds for the player build kit: wood, stone, metal and mushroom. Meanwhile, the dynamic music system is still in the early stages of planning, with more info to come soon. Now, while it's been a long 5 months, this is all we have to show right now. The move from UE4 to UE5 along with the networking solutions have taken up most of our time in the past 5 months. However, we will continue to work hard on this and make sure that we get exactly where we're aiming to be. So stick around and wait for the next devlog to see more features and more function. And as always, a massive thank you to the patrons. You guys are absolutely awesome. If you're watching this as it premieres, I'm going to be live over on Twitch playing some games and chatting to you guys about Nightmare World. If that's not for you, that's totally understandable, and until next time, take care.